So we are currently at the receiving bay at Safisana. And Simon, what are these that we are seeing?
Okay, these are industrial waste. That is waste from industries that we process.
So all of these that we see, the whitish substance, are all milk?
Yeah, milk, dairy, yes.
Okay. What are we seeing right now? They look
yeah,
broken down somewhat, or?
Yeah, before we receive the waste on site, we first do distraction. So
What
that
is
it become
distraction?
unwholesome for people to consume or for anyone to tamper with. So when the waste comes, we first add our digestive, that is the liquid from the digester, to it to make it unwholesome for people to take. Yeah.
But it's only after you have received it that you have to destroy it.
Destroy it, yeah.
So this is chocolate?
Yeah, chocolate, yeah.
Very sad.
Yeah.
So what quantity do you receive in a day or in a week?
Yeah, so for industrial waste, currently we receive about 6 tons from Nestle, and also for tomato waste, that one it is not on weekly basis, but I'll say sometimes 2 weeks we receive one trip, and it's about 40 to 60 tons. But I'll say in general, in a month we receive about 200 tons of industrial waste. In a month.
And this is where you store them?
Yeah, this is where we store.
And then you sort of have to destroy it before you are able to turn it into usage material.
We can actually start processing it, but because sometimes the quantities are quite high or enough, we can't process all within a short period. So we need to also distract it so that people cannot actually pick it up. Yeah, so that's why we need to do the partial distraction before we start feeding it.
Does this mean that these are expired milk and Milo and the like?
Some are expired, but some too could not meet the quality test by the industry, so they have to actually dump it at the landfill. But Safisana, we are into treating waste, not allowing it to go to the landfill. So that's why we actually receive and treat it here.
Okay, so take me to this other material. Okay. Very interesting looking waste. What is it? What is this that we are seeing?
So this is also from Nestle, and it's known as Cerelac. But locally we call it Banku, but it's Nestle waste.
Yeah. What's the difference? So this is actually Cerelac,
yes,
that has gone bad.
Yeah.
And then why is it Banku?
Because of the bulky nature of it, so it looks like Banku. Looking at, even if you don't take it, you think it's kinky.
Yes.
So that's what that's our local term that we give to it here. So we call it Banku.
Okay, but standing here with you, I'm not smelling anything really bad. Should we not be smelling, or have you done something about the smell?
Yeah. So what we currently do is we actually know the capacity of our plant, so we don't allow the materials to stay here for long. If they are staying for long, that's where you start having those pungent smell.
Okay.
And this type of materials too are actually, some of them are semi-solids and also solids.
Okay.
If they come into contact with liquid or water, that's when they start degrading and you start experiencing the offensive smell.
But how long does it take before we would ideally start smelling something bad? Let's go here.
For now, I can't really give you, because most of the waste that we receive, we process them within a month.
So Simon, what is this? What are these I'm seeing here?
Okay, so these are tomato paste waste from industry. So industries that produce tomato paste, some of the products go bad and they bring it to us to treat.
Is it then not the case that if it is tomatoes that you are processing, tomato waste that you are processing, you know, every year we have tomatoes in Akumadan and all those places going to waste. Can you not sort of, Safisana, have a way of bringing those to add on to what you're already processing?
Yeah, we can't do that, but the challenge is the cost of operation, the transporting it from Akumadan to here, and the cost of the transport, that we don't have our own truck. Mm-hmm. So that means we need to even outsource to someone, and in terms of operational cost, it will increase our operational cost.
Okay. I mean, we are trying to do everything. Ayiko. Yeah. So with what they are trying to do, they are digging from here and dumping where?
into the mix pit. This is where we actually do the feeding. So on a normal day, a recipe is sent that is with all the various waste sources we have on site. We know some characteristics of each of them. So our target is to produce a particular amount of gas. So based on the sources available, we try to feed towards achieving that particular quantity of gas that we want to produce.
I realize from these also that as you are trying to reuse or treat the waste, you are creating some more waste. What do you do with this?
Yeah, so these plastics, currently we've identified a recycling company in Ashaman, and what we do is we actually pack it for this company to come for it, to recycle the plastic.
Do you sell?
We sell it.
You sell them. Okay.
And then with the drums, these ones, we have two ways of dealing with the drums. We have some of them, the companies that bring the waste are still interested in the drums. So after feeding, they come for their drums. But
Okay.
those that are not interested, we sell, and then we try to make something small out of the drum.
Spoken about the milk, but what is this Simon?
So this is where we receive the fecal trucks. That is the septic trucks that dislodges fecal waste from household and also public toilets. So for Safisana, before we receive, the truck first goes to the weighing bridge. Then after weighing, it comes to dislodge here.
Okay. Now, how is this connected to the milk and the tomatoes that we were talking about?
So with the milk and the dairy, the tomato and the Cerelac, they're in a form of solid. So you need something liquid to actually mix it. So for us, our main interest is also treating fecal waste.
You do not produce sludge after you've treated the fecal matter, do you?
We produce sludge, that is after the gas generation. So,
Gas generation.
Yeah, so the fecal actually comes into the mix pit, then we mix it with the various industrial waste. So
Okay.
this fecal storage tanks. So we store fecal materials in there. We have Safisana has a public toilet, so this is our public toilet, and it's connected to one of the fecal storage tanks.
Are you able to harvest enough fecal matter?
Yeah, according to our, I would say, data, every week we get one tank being full. So from our fecal, our public toilet.
Should you then not be marketing your toilet facility so you can harvest more? You need more,
Yeah,
don't you?
yeah, we need more, but we also want to treat what's also in the, because actually Ashaman is a high water table area.
Okay.
And setting up an on-set fecal treatment facility, it's impossible because of the high water table levels.
We
in
can step
Ashaman.
on this?
Yeah.
Yeah, sure? Okay.
So that's why we have actually set up an off-site treatment facility. So we also, in our quest for treating fecal, we also treat fecal from outside as well.
Wow. So I don't see any gauge with how they're just dumping these inside. According to your recipe, what quantity is supposed to go in today?
Yeah, so we have the tank that we are standing on currently is a cylindrical tank.
Okay.
So we have the area of the volume. We know the volume of this tank.
Okay.
So what happens is, as we put in the fecal, we use a stick, a dipstick,
A dipstick.
yeah, to check the level, and with the level, we measure the height of that, and that gives us the estimated volume. So that's how we are able to measure the quantities we are feeding.
How deep is what we are starting? How deep is this tank?
This is about, in terms of height, it's about 100 centimeters. That's a meter.
Okay. Well, I mean, use this building as the measure for those who don't know what 100 centimeters
So
would be.
it will be like using, let's say, from the tip of this door of the gate to where the padlock is.
Okay, so it's not too
could-
deep.
Yeah.
It's not too deep. So how long do we have all these mixes staying here? How long do they have to stay before, is it what happens? Is it fermentation? Is it what is happening here?
Yeah, so for this end, it doesn't stay for long.
Okay.
This is just a mixing stage.
Okay.
So within 1 hour, we are able to do one mixing. On a normal day, we do about 2 to 3 feed in a day. So what happens is in the 1 hour after mixing everything, adding everything up, the feed pump over here actually uses pressure to mix the material homogeneously, that is
Okay.
thoroughly, and that is transported to the digester.
Okay.
So that's where it stays for long.
Okay.
So it's now doing the mixing.
Yeah, some. Wow. How long do we even have to mix?
So we do it for about an hour. For the mixing, about 15 minutes. We do the mixing and we transfer it.
Okay. Then from here, we move.
So it moves through the pipe into the digester.
Okay. Tell us about the digester. This huge, what is it? Is it a netting? It looks like a mountain. It looks like a big rock. We don't know what it is.
Okay, so this digester, the capacity is about 1,500 cubic. That is the volume of the digester. And this digester is an anaerobic digester, meaning there is no oxygen in the digester. So the feed that we transfer from the mixed feeds into it undergoes anaerobic decomposition decomposition. And during that process, we have microbes in there. That is, in our normal dialect, we say germs or gogomi in there. And then these germs break down the organics to produce the biogas that we are interested in. Before you see this green balloon,
Yes.
there is a white balloon beneath this green.
Okay.
And this white is what contains the gas.
Okay.
So this is just a protection, but the white in there is what contains the gas.
The recipe has fecal matter,
Yeah.
has tomato or, tomatoes, waste tomatoes, has milk, has a bit of Cerelac,
Yeah.
and then what else?
I
I didn't hear of vegetables.
No, for the vegetables, those ones are, and the market waste, those ones are used for composting. So when we get to the composting and we'll have those materials, we don't feed them into the digester. And because we also produce compost, so those ones are actually added to the sludge from this process, and we do co-composting to get the compost.
So after all is said and done,
Yeah.
we have electricity that is
Yeah.
generated.
Yes.
And you onward sell
To
to ECG.
Yes. Yes.
Thank you very much.
No.
So Simon, after we've gone there to deposit the fecal matter, a part of it has been used in the mixing for the electricity. Tell us about how some end up here.
Okay, so our system that we use is a continuous flow system, meaning as we feed into, we need to pump something out. So what happens is when we are pumping out, we pump onto these beds.
Okay.
These beds are actually termed as drying beds. So on the drying beds, it's a filtering media. Like in local term, we say sonier.
Okay.
So it's able to sieve the liquid parts, leaving the solid parts on top of it. And the solid part is what we scoop to produce our, and also add market waste to produce our compost.
So what we have here is what you've done with the market waste
Yeah.
in addition.
Yeah.
And then when we are done, we bag.
Yes, please.
Okay. And then you sell to the farmers.
Yeah.
Right. This is a very interesting business model. So Simon, after the drying and the mixing with the waste from the market, Then what do we have?
So we now get a new, our finished compost known as the Asase Different. This is
Okay.
how the compost looks like.
Okay.
Very rich in organic matter and also nutrients. There is nitrogen, phosphorus, and potassium.
And your ultimate market for these products are what? Farmers?
Farmers, yeah, and also bigger farms, that is in that commercial farms as well. Those are our main targets.
Interesting. So now you're taking us to your lab,
Yes, ma'am.
right?
Yeah.
And so something like that can be used, and how you are even trying to utilize your organics, right?